Hey everybody, it's Dr. Jensen, wrapping up interpreting coefficients on our example. Remember we were looking at the question of how many children do people have and whether or not we can use age, their opinions, or on premarital sex, or whether they have a college degree. So I think we left off here with this negative 0.481. People who have a college degree have a 0.481 decrease in the number of children they have compared to those who do not have college degrees. In other words, they tend to have almost half a child less. The relationship is significant, indicating there is a relationship between having a college degree and how many children you have. So whenever you have a nominal variable, whether it's a recoded variable or it's categorical or some way, you always have to write up the result in terms of who you are comparing them to. So you start with the group who's a 1, and you compare them to the 0. Males versus females, black versus white, people who have college degrees versus people who do not, okay? So the coefficient pertains to the people in the 1 group. The 1 unit change goes to the people in the 0 group. So people in the 1 group experience this compared to people in the 0 group who don't, okay? That's how that actually works. Again, that's why we do those recoded dummy variables so that we can make those kinds of comparisons. Okay? The constant, that's back up here. So we had a little constant, or this is our y-intercept, 0.190. That means, not knowing anything about you, we'd expect you to have 0.19 children or slightly more than 0 children. Again, we don't like to think about portions of a child, but when you're doing statistics, you'll get those kinds of proportions. Okay? And overall, the model summary, and remember, model summary usually has a little list of the variables inside your model. So those are the college degree, age of respondent, and the opinion question on premarital sex. All of these 3 variables combined contribute to 0.179 of the variance, or basically we change that to a percent, so multiply by 100. It's the amount of the variance explained. So 17.9%, or almost 18% of the variance on the dependent variable, how many children somebody has, can be explained by knowing these 3 things about them: age, college degree, and premarital sex opinion. If I know these things about someone, I can predict about 18% of all the responses in number of children pretty accurately, okay? So I can get pretty good on coverage, but again, that's not great. A higher number would be better, right? So we call that, it's not a strong relationship, it's kind of weak and moderate. I don't get a lot of coverage by knowing these things to be able to explain all the different answers people have on how many children they have, okay? So there's one more example here at the bottom. I'm not going to go through this one. You can look at this one on your own, maybe kind of test yourself walking through it. The document is on Canvas, so you can kind of follow along and look things over. And it makes some good points about, how you do your comparisons, what you find in your output, if you're comparing department versus department, county versus county. But it always comes back to, how do you measure something? What kind of information is in there? Is it a category versus a category? Is it a number of how old somebody is or how much money they have? So all this stuff really matters because it's going to drastically change what we say about this statistical test. Okay? So hopefully just kind of reviewing and getting to know these kinds of principles will help you practice them on your lab. So I'll be recording a few videos to help you on your lab, but you're going to again be kind of making decisions on your own about whether or not something should be recoded, because if you're doing analysis one day, no one's going to be looking over your shoulder saying, hey, you should recode that. You're going to have to just know what information is in there and how it gets analyzed to make the decision on whether it should be recoded or not. So we're going to get more practice at being independent and doing some problem solving on our own. But again, feel free to reach out. I've walked people through how to do this on phone calls where we've gone step by step together. I'm not opposed to that at all. I think it's helpful. But again, work in teams and kind of logic and problem solve this together. So this is basically linear regression in a nutshell. All the output you get, all the little pieces, and what it means. So if you have questions, let me know, and good luck.